So hi guys, let's start a new video. So we did an experimentation in the previous video. So let's continue our series and continue to the next problem, that is count inversion. Let's see what does the problem count inversion says. Count inversion says that given an array of integers, find the inversion count in an array. And what is inversion count defined as? So inversion count is defined as, for an array, inversion count indicates how far or close the array is from being sorted. If the array is already sorted, then inversion count is 0. If an array is in sorted and in reverse order, then inversion count is the maximum. Okay. So formulate two elements ai and aj form an inversion if ai is greater than aj and I is less than j. This is an important condition to know. Okay. So what we were given there, ai is greater than aj and I is less than. So, for example, let's consider this is an example array. What would be its correct sorted order? That would be 1, 2, 3, 4, 5. So the inversion count property says that if I is less than j, that if I is less than j, that is the element I is present here and the element j can be present in the right word. Okay. If there is any element here which is greater than this element, then inversion count more plus plus. I hope I'm clear what I'm saying. For example, for this array, let's find the inversion count. The first inversion count can be 2, 1 because 2 is lying in the left of the 1, and but 2 is greater than 1. So 2 comma 1 is an inversion. Then enough for 2. After coming to 4, 4 comma 1 is an inversion. 4 comma 3 is an inversion. After that, enough for 4. After that, 1, no inversion, 3, no inversion, 5, no inversion. So the total number of inversion here is 3. So what is the brute force approach for it? So the brute force approach is very evident, very clear. Let's start a loop from the first element going up till n minus 1th. And then for j equals to I plus 1th element up till n minus 1. If array of I is this point, it should be array of I is greater than array of j, count plus plus. Declare a count equals to 0 here, and then after all the loops return count. That is the final answer. Time complexity, I don't think I need to mention it. It is O of n squared. Okay. But could it be more efficient? Let me clear the page for you. So let's keep aside the concept of count inversion. Let's keep the concept of count inversion aside and focus on another concept. Okay. Suppose I have two sorted arrays. Okay. Let's say the first sorted array is 5, 8, 9, 12. Okay. And the second one is 2, 4, 6, 15, 18. Alright. So that you have got our arrays, you can check they are sorted. I say the find the inversion count in them. In sense, like inversion count, like if the element present here is smaller than present element present here, count plus plus. You understand what I'm saying? I'm saying if an element 5 is greater than any element present here, like 5 is greater than 2, so 5 comma 2 is an inversion. Then 5 is greater than 4, so 5 comma 4 is an inversion. Then 8 is greater than 2, then 8 comma 2 is an inversion. 8 comma 4 is an inversion. 8 comma 6 is an inversion. For 9, 9 comma 2 is an inversion. 9 comma 4 is an inversion. 9 comma 6 is an inversion. For 12, 12 comma 2 is in inversion, 12 comma 4 is in inversion, and 12 comma 6 is in inversion. Rest, I'm not able to see any other inversion here. So what are my inversion present are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 is our inversion count here. I think you have got my problem, what I'm saying. You got the hang of it. Let me clear the page for you. Yeah. So how can we approach this? Simple, we can use the brute force approach defined above, that for 5 traverse the whole array, for 8 traverse the whole array, for 9 traverse the whole array, and for 12 traverse the whole array. Okay. We have discussed that approach. Let's try a new one. Okay. So what I'm saying is, come to 5. Keep in pointer I here. Keep in pointer j here. Okay. You observe 5 is greater than 2. Okay. Let's keep an array which are using, just like in the question we used to merge the two sorted arrays. Keep an array. Okay. So 5 is greater than 2. Okay. So 2 will come here. Now count should be increased by 1. 5 is greater than 2. But, here comes the catch. If the array is sorted, this array is sorted and this 5 is greater than 2, doesn't it conclude that all the elements present at the right of the 5 are also greater than 2? You can check also if 5 is greater than 2 and all the elements present in the right are greater than 5. So automatically what I'm saying is that this be A and let any element present in this array is B and this be C. If we have two conditions, that is A is greater than C and B is greater than A. So can I conclude B is greater than C? So if 5 is forming an inversion pair with 2, all the elements in the will also form an inversion pair with 2. So instead of adding only 1, can I add 5, 8, 9, 12? That is 4, forming a inversion pair with 2. Okay. Okay. Done. Deal done. Got my point. Simple as simple enough. That if 5 is greater than 2, then all other elements are greater than 2. So they also will form an inversion pair with 2. Okay. Added 4, waiting for the next term. Okay. So now, because 2 got here, j moves forward. Okay. I is still here. Again, you observe 5 is greater than 4. Now, if 5 is greater than 4, then all other elements will also be greater than. So, 4 comes here. Okay. J moves again forward. Now, 5 is less than 6. So, we keep a 5 here. We do not increment anything. Make our I here. Now, 8 is greater than 6. So, every element greater than 8, that is 8, 9, 12, is greater than 6. We are able to find that there are 3 elements. So, plus 3 for that case. After that, J was come here. J has to come here, so J will come here. Now 8 will come. I will move forward. 9 is still. I will move forward. I will go out of bound then. Then we can easily put 5 and 18. Okay, so our total answer is 11. If you remember, the correct answer we mentioned here before I deleted the part, it was also 11. So our answer is matching. We can use this algo. So this gives me an inference. Let's the example array given to us is, I forgot that array. Let's make a new one. Suppose we have been given 5, 6, 2, 1, 7. Okay. Suppose by some way, if I'm able to convert it into two sorted arrays, then while merging, I can use what we used before, which I showed you in the algorithm. I can use our knowledge. Okay. But if you see here, it says while merging two sorted arrays. Does that ring a bell? In my mind, it does. Because maybe because I know the answer. Just a lame joke. Just keep focusing. It is saying merging to sorted arrays. Merging to sorted arrays. Also, we have to construct two sorted arrays from it. Can you now understand where I'm pointing it towards? I think I've given enough hints. What was the algorithm of merge sort? We had an unsorted arrays. Okay. We divided it into the parts. And then we merged them. If it reached after it reached one element each, we merge them, and we merge them as sorted arrays because one element is sorted in itself. No, so we are merging them and making a sorted array and climbing up the tree. So this array is also like same now. What if I have the 5 here and 3 here? It is an inversion pair. So while merging, if I count the inversion count, it would be 1, and suppose it gives 2. So I return 1 from here, 2 from here, and this will return 1 plus 2, that is 3. So I think I can use the merge sort algorithm. Okay. So let's try and use it. How we are able to use it? Let me draw you a tree. I say the array was 5, 6, 2, 1, 7. I say don't think about counting version right now. Just make me a merge sort tree for it first. Okay, you say yes, boss. Let's make it too. So the tree would look something like this: 5, 6, 2, 1, 7. Okay. After that, 5, 6, 2. Okay. After that, 5, 6. Okay. Let's study the left part because also in the recursion, left part is solved first, then the right part, and then they are merged. Correct? If I'm not wrong. Okay. So now merge them. Now, while merging, use the algorithm we discussed to find the inversion count. Okay. So while merging, I see 5 is less than 6. So this does not need an inversion. So 0 for this inversion. Okay. Returned. 5, 6 is already in sorted order. Comparing 5, 6 with 2. Alright. Now 5 is less than 6. Is greater than 2. Inversion. But if 5 is greater than 2, does that conclude that 6 is also greater than 2? So add 2 to it. Alright. Now, when what we have done is we had the sorted array as 5, 6 and 2. I was at 5 first. I gave 2 to the answer. I came here. J was here. 6 as already J was here. I didn't came in. J got out of bound. So our array becomes sorted array becomes a 2, 5, 6. So after returning, it becomes 2, 5, 6. All right. Now the two arrays we have to solve for are 2, 5, 6, 1, 7. I here, J here. I is greater than J. So we have to include 1, 2, 3 into the answer. Plus 3. Okay. Keep 1 here. Move J forward. Okay. 2 is less than 7. I will just move forward after keeping 2 here. 5 is less than 7. 5 will be here. I will be here. 6 is less than 6 will be here. I will be out of 1. So we keep all the elements 1, 2, 5, 6, 7. So these two will give 1, 2, 5, 6, 7 as an answer. Our sorted array. But what is the final answer that we wanted? That is 5. This is a working. Okay, I've showed you the recursion. Okay. Let me try to include it. How can we solve it? Okay. So as I showed you that we have to use some modification in the already written merge sort array. We have solved the merge sort array already. You can check my playlist. I will provide a link in the description also. So I'll just copy pasted the code for merge sort here, nothing else. I will just format it so that it returns good answer for the inversion count also. Alright, so long int answer equals to merge sort for ARR. Lower limit is 0 going up to n minus 1. I hope you remember that. Return the answer. Alright. Now, what does the merge sort do? It is returning answer. So, what would have to change? Up to till long int. Okay. If low is greater than high, okay, return 0. Otherwise, mint. Keep a counter here for the answer. Long int. Keep it as 0. Okay. And v equals to 0. I don't think I have to explain why I'm adding INV. Why I'm adding the results into the INV. These are pretty evident. Okay. Long int merge. So now here also I have to keep INV. Okay. Now what we are doing, we are merging them. While I is less than equals to mid and j is less than equals to I, okay. If error of I is less than equal to j, we have to sparse this condition because the left element is smaller, so no inversion. Okay. What if right element is greater? Right element is greater. Sorry, right element is smaller. In that case, we have to do an inversion. Now, what is the case here? We are dealing in only one array. Okay, as subparts because of we the pointers low, high, and mid. The code written is showing the examples like this. The array is this. The first array is up till here now. Okay, let me mark the indexes like this. So the first subarray contains all the indexes which are dotted, and the rest one is dashed. Okay, so what my code is doing, my code is low here, high is the last index, and mid is the this index, this one. So the first array is from, look at the brackets also, it is square brackets, so including mid, and second array is from mid plus 1 to high. All right, so consider the sorted array as this. Suppose here is the inversion we found for this element. Okay. Suppose n equals this is n. Okay. I is this element index. Okay. So what will we have to include? We have to include 2. Okay. This condition I here is n minus 2 as depicted in the figure. So for obtaining 2 is n minus I, which is equals to n minus 2, so it will equal 2. But we can observe that mid is the last index, so mid is equals to n minus 1 here. Okay, we need n minus I. So can we do minus I plus I here? Now mid equals to n minus I, which is our answer we want, minus I minus 1 plus I. So n minus I equals to mid plus 1 minus I. I hope you understand. So what we have to do here, we just have to do INV plus equals to mid minus what we said plus 1 minus I. So minus I plus 1. Alright. At last, return INV. So we have completed our merge, and here we have to return. Seeing if you compile and run. Hope I have not committed any mistake. Oh, like always, mistake has been committed. What? Semicolon. Even I am ashamed to say that I have missed the semicolon. Okay, running fine. Let's try to submit and then end the video. Oh, it has been submitted correctly. Thank you guys for watching the video. It was a total pleasure to teach you. Also, if you like the video, please don't forget to subscribe and keep watching the videos. I will bring more content, more interesting content for you. Also, please don't forget to like and subscribe. Thank you. Have a nice day.